better to read, but I'll read them. Number 1 was 2 over b. 2 was 1 over k to the third power. 3 was 2 over n to the fourth. 4 was 1 over m to the fourth. 5 was negative 2 over m squared. 6 was 2 u squared over v. 7 was 4x cubed over y. 8 was 4b to the third over a to the third. 9 was negative 3 over a. 10 was negative 4 over u to the third. 11 was 4 over p squared times q times r to the third. 12 was, I didn't box that one, 3x to the third, z to the fourth over y to the fourth. 13 was negative 2m squared times q squared all over p to the fourth. And 14 was negative 4m to the third q squared all over p squared. Do we have questions on any of those? We're good with those? I see some people still checking, so I'll give you a minute. What's number 11? This. Right, and then let's go over one of the strike right answers. Show me which one you want to do the most. Some of you don't have your hands raised. If you are 4, raise your hand. 5, 6, 7, 8, 9, 10, 11. If you are 3, raise your hand. If you are 2, raise your hand. I think I had some class, but it wasn't as many as 11. So we're gonna do 4. How do we start solving this? Cross multiply. Take this numerator, multiply it to this denominator, and vice versa. Does not matter which side you put on which. 5x minus 2 equals 2 times x minus 8. And then how would we start solving this? Distribute. So we have 5x minus 10 equals 2x minus 16. Now we can move whatever we want. What do we want to move? The 2, okay. So we're going to subtract 2x on both sides to get 3x minus 10 equals negative 16. Still need to get x by itself, so what would our next step be? Add 10 on both sides. we have 3x equals -6 and divide. So x equals -2. Okay, make sure you have that written down as of your answer sheets. Does anyone not have this packet of notes? Alright, so we're going to go back to when we were expanding these, writing them out. You have a question. How would I expand x squared? X times x. How would I expand x to the fourth? Could we combine all of those? What did you say? Well, all of them. I mean, they are all multiplied together. Could we condense them so that it's x to some power of something? X to the 6. And really, we just counted those up. For 2, if I expanded this, I'm also going to rewrite this a little bit. I'm going to move the 4 so that they're next to one another. I have this first a. How would I expand a to the third? So I already moved this 4. I'm just talking about a to the third. A times a times 2. Now, if we were to condense this, what would that be?
Or a to the 4th power.
It would definitely be a to the 4th power, but it would be 16. We'll do one more, and if you think you know what the rule is, then you can say it. For this, how would I expand n squared? N times n. I'm going to move this 4 out to the front. Remember, the reason we can do that is because multiplication is commutative, the order doesn't matter. How would we expand n to the third? I can also move this 7 out. I forgot it had 2 numbers. I should have done that at the beginning. Sorry. And then because this one just has a single n, I'm just going to put that at the end. How would I condense this? To the 6th power. Anyone figure out the rule? What is the rule? What did you figure out?
If you have 4, like 4 and 7 combined, and then how many
You're talking about if we expand them. I'm talking about looking at the exponents. Could we come up with a rule by looking at the exponents? Is there some relationship between these exponents? We're adding them together. So if I redid this and I said 2 plus 4, I would get 6. If I rewrote number 3 and said 4 times 7 times n to the 2 plus 3 plus, what's our exponent here? 1. Remember, even though, so I circled it, but even though it's not there, it is a 1. And if we added those together, we would get 6. Now, let's see if that rule still applies for this one. I'm gonna go back to expanding for 1 second. How would I expand c to the fourth?
4 times c times c times.
D to the negative third. What does that look like? It's 1 over d to the third. I could change this because we can expand d to the third by saying 1 over d times 1 over d times 1 over d. That would be the same thing. And then expanding c squared would give us c times c. If we combine these, what would this look like? Let me ask this. Can we combine our C's and our D's? No. So let's do it one at a time. Let's combine the C's. How many do we have? 6. So that would be C to the 6th power. We know this is the same thing as 1 over D to the 3rd power. Can I combine these fractions? Yes, you can. Because I can put this over 1 and multiply across. What would that be multiplied across? What's c to the 6th times 1? What's 1 times d to the 3rd? So we did combine them in a way, but not in the way we were doing before. Here, we did still add those two, but we didn't add the negative 3 or didn't do anything with the negative 3. So, should we reword our rule? We know we can add the exponents, but only if what? I want you to think about that as you go to lunch. Go ahead and grab your phone. Okay. So how could we change that rule of add the exponents if they have different variables? If we couldn't add them when they have different variables?
What question are we on?
I'm asking you to think of some way to word our new rule for adding the exponents, but we couldn't add them here because they have different variables. How could we state a rule for those two things? And then put your phone up. Sorry. Any ideas? We know we need to add the exponents, but we can't add them always if the variables are different. This is going to be something you guys make up, so we can sit here all day. came up with was we could add the exponents, but we know we can't always do that. Maybe did you have an idea? Say what? Not really. So we're still using the rule, we can add the exponents, but we have to somehow restrict it or make it more specific about what happens when we have different variables. Or we can keep expanding until you guys come up with a rule. Some of these are going to get really big really fast.
What are we doing?
Coming up with a rule. We know we can add the exponents, but we can't add them always. Zia, you were going to say something.
I was just thinking about
You add the exponents.
But we need to be specific, because we can't do that. Did we not add the exponents because one was negative? Why didn't we add all of the exponents? Because the variables are different. You guys are close.
if it's different variables.
Okay. So let's put that and adding exponents into some sort of rule. Instead of saying for different variables, why don't we talk about the same ones? So what can we do with the same variable? We can add the exponents of the same base. So if the bases aren't the same, we can't add the exponents. For number 5, you have x's, you have z's, you have y's, and you have numbers. The numbers don't count as being the same base because you can combine them, you can multiply them. So you could rewrite that, put all of the numbers out front. Those parts don't matter. You will multiply them. Do you have x's, multiple x's?
Yes.
Yes. So if we can add exponents of the same base, what two exponents are we adding?
No. I mean 8 and 1.
8 and 1, because this one has an exponent of 1, which would give us 9, yes. What about y? Do we have any, do we have multiple y's? So in this case, it would just be y to the 4th. It's not going to change. As you're doing this and you have a lot of variables, try to put this in alphabetical order. That'll help you out the most. What about z's? Do we have multiple z's? Yes. Yes. So what exponents are we adding? 2 and 1. And then we can condense it. What's 5 times 2 times 3?
30.
30. X's new exponent would be 9. Y would not change. Z's new exponent.
30.
Now, if we were expanding, we would still have these 3 numbers out front, but then we'd have 1x, 2 z's, 4 y's, 1 z, 8 x's. We'd have to add all those up. which can still be done, but it takes more time. Yes.
How did you get like where it says x1 plus 8? How did you get the 8?
Just 8. Or you're talking about where did the 1 come from. So anytime you have a variable by itself, it has an imaginary exponent of 1. It's not there. It will never be there, but you have to remember that it's 1. For 6, again, you have numbers you can pull out. I see we have x's and we have y's. So in alphabetical order, do the x's first. Do you have multiple x's? No. So that one's not going to change. Now you have multiple y's, but one of your exponents is negative. So instead of saying 3 plus negative 7, you can just write 3 minus 7. We're still adding, but we're adding a negative, so we end up subtracting. What's 2 times 7 times 2? 28. X squared. What is our new y? Y to the negative 4. Now, can we leave this like this? No. Why not? Because we have a negative exponent. We cannot leave negative exponents. So what would this become? 1 over y to the 4th. So if we combine these two, what would our final answer be?
Wouldn't you have to turn 28x into 1 over 28?
No, because the negative 4 only goes to y. It does not go to x or 28.
X squared over y to the 4th power.
Yes, you just forgot 28.
Oh.
So our final answer should be 1 condensed fraction. No matter what else you did to get there, your final answer should be 1 condensed fraction.
How'd you do that?
Which part? Multiply across. Remember, all whole numbers are over 1. 28x squared times 1 is 28x squared. 1 times y to the 4th is y to the 4th. Let's go to the next page. Again, we're going to start off by condensing, and then I want you to find the rule. X to the 3rd to the 4th. That would be the same thing as x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. What do we know about the same exponents with the same base? We can add their exponents. So what would this be? X to the 12. Do we think we know the rule yet? If we do 8 to the negative 4 to the 7th power would be a to the negative 4 times a to the negative 4 times a to the negative 4 times a to the negative 4 7 times. That's 5. 6, 7. We know that we can add or subtract our exponents because they're all the same base. Five, 6, 7. What would that be?
A to negative 28 power.
Negative 28. Can we leave that like that? No. So what would a to the negative 28 be?
1 over 28 power.
Correct. Have we figured out the rule? How are we relating the exponents? How are the exponents related? You can keep expanding until you do. Right here, we have c to the 5th. Here we have c to the 3rd to the negative 2. How do I want to do that one? Because we don't have the exponents before. I'm going to write this like this. One over c to the 3rd squared would be the same thing as c to the 3rd to the negative 2. So I could rewrite this as 1 over c to the 3rd times 1 over c to the 3rd. We know if we have the same base, we can add the exponents. I didn't really need to expand this, but we did. This would be 1 plus 1 plus 1 plus 1 plus 1, so c to the 5th. We could add these two. To get c to the 6th. Oops, I read that backwards. It's not completely simplified, but we'll do that here in a second. Have we figured out what the rule might be? Is there any relationship between these numbers and this? Multiply them. If what?
What if exponents are
No, because it's raising it to a power. I will remember that. You said number 9's exponent is positive. Yes, what about it? Change it to what? Change the exponent to a negative? I was going to say it would, yes, but then we did our mathematics. You shouldn't have negative exponents as your final answer. Look back at your rule for the last ones we just did. We need to be very specific. You know, we can multiply them, but if what? Only if they have the same roots. We can multiply our exponents if they have the same base. And that's your power of exponent rule. So if you are raising an exponent to another exponent, you can multiply them if the base is the same. For this one, I'm going to go back because you have this c to the 5th over this c to the 6th. When you simplify these, you should only have one c left. We haven't talked about how to divide yet, so I'm going to go back to something we do know. We put c to the 6th down here, but if I rewrote this as c to the 5th times c to the negative 6, that would be the same thing. I did mathematics backwards. Usually we see the negative and we make it the fraction. I took the fraction and went backwards. Because now we can combine those.
So you don't get the fraction?
We haven't talked about the rule for the fractions, which is why we're not doing it that way. Usually it wouldn't matter. Once you know the rule, it doesn't matter. How would we combine these? Add the exponents. Or in this case, subtract the exponents. C to the negative 1, can we leave that like that? No. So what would our final answer be?
1 over c to the first power or the c.
Just C. You don't really need to write 1 over c to the first power. If we had went back and actually used our rule here, I'm raising an exponent to another exponent, I could have multiplied my exponents and then added my exponents, so I really didn't need to do all of this. For these, if you multiplied 3 and 4, you would have got 12. You multiplied these two, you would have got negative 28 and then had to flip it. So if you know your rules, this works a lot faster. So with this one, we are raising an exponent to another exponent. This is very similar to the ones we did when you did problems on the back of your warm-up. You are going to multiply those two, but because 2 is inside those parentheses, you also need to multiply this exponent. So I'm going to rewrite that so you see it. This is the same thing as 2x squared to the 3rd. You could separate it, you don't need to. I would do this only for practice so that you remember it goes to both and not just one of them. 1 times 3 is 3, so that'd be 2 to the 3rd. 2 times 3 is 6, so that'd be x to the 6. What's 2 to the 3rd? 8. Yes. 2 to the 3rd is 2 times 2 times 2. So if you have whole numbers to some positive power, if you don't know what those are, you can check them in your calculator. You can use your caret for any exponent. There are some in math that I want to show you, so you don't have to do the caret and then 3. If you go into math, At number 3, there's a little 3. Kind of looks like it's an exponent. That is your to the third power. So you could use that instead of using the caret, the arrow 3. And it'd be the same thing. Or you can say 2 to the third power, or you can say 2 math 3. Both work. Okay. Now we have a bunch of exponents. These two are multiplying. This 4 is multiplying to the 2. It's also multiplying to x's exponent and 3's exponent. If you need to rewrite it, you can do that. This part is the same thing as 3xy squared all to the 4th. The separating it like that is not necessary, but if it helps you, do that. If I'm multiplying my exponents, this would become x to the negative 4th. This would become 3 to the 4th. This would become x to the 4th. This would become y to the 8th. Do we have any of the same bases? Yes. What? X. So I'm going to rearrange this a little bit. I'm going to move 3 to the 4th out front and put my x's together. If I have the same base, I'm doing what to the exponents? Adding them, in this case subtracting because it's a negative, but what is 3 to the 4th? 3 to the 3rd is 27. So if you multiply that by 3 once more, or do 3 caret 4, you get 81. When we combine these, we get 0. What happens when we have 0 as an exponent? You get 1. So our answer is 81 y to the 8. The x's completely disappeared. We started with 2 and now they're both gone. That will happen sometimes. Alright, let's do this last one. Same thing. You can separate it. You don't need to. I'm going to, since we're still practicing. This 5 is going to the 3. It's multiplying. It's also multiplying to 2's exponent.
Wait, can you just go back to number 11 real quick? How did we get rid of x?
They canceled. Became 0.
But how
Anything
did it
to the
become a
0
negative?
power. This was already negative.
And how, well, negative 2 times 2 is 4.
Negative 4.
But since it's to the... Never mind.
This 3 is going to go to each, multiply to each exponent. I'm going to expand that so you see it. We have 2 to the 1st to the 5th, a to the 3rd to the 5th, negative 3 to the 1st to the 3rd, a to the 1st to the 3rd, and b squared to the 3rd. multiply your exponents. 1 times 5 is 5. 3 times 5 is 15. 1 times 3 is 3. I'm gonna put that on the inside. 1 times 3 is 3 again. B squared to the third power would be what? If you're multiplying your exponents, b to the 6. Just like this problem, we're going to rearrange, put our numbers out in front. Here we have 2 A's. We're multiplying with the same base. What are we doing with the exponent? Adding. And then B is by itself. What is 2 to the 5th? 32. What is negative 3 to the third power? Negative 27. A's new exponent would be 18. So the last thing we need to do is multiply 32 and negative 27. 864. Negative 864. You will get big numbers like this. Right, so far we know 2 of our rules. And I was actually mistaken when I said this. When we have exponents raised to another exponent, you really only have 1 or 2 bases. So it doesn't matter if the base is the same or not. You just multiply the exponents. But if we are multiplying like bases, we are adding our exponents. And now we're dividing. Anyone want to take a guess before we start expanding? Subtract the exponents if the base is the same. So, before we actually do these problems, I'm going to go back to one of the problems where we had a fraction. For number 9, when we ended up with c to the 5th over c to the 6th, if we had subtracted then, or knew our rule for dividing, we could subtract these and still get the same answer. Colin, can you shut the door? Thank you. So if we are subtracting now, I can rewrite this as a to the 6 minus 2. So a to the 4. Just to show you that this still works with the expanding, we won't do this for all of them. If I had 6 A's here and 2 A's here, I could divide this by saying these are the same, and I have 4 left. So the expanding method still works. It will just be a lot. Do we have like bases here?
Yes.
Yes. C and D. Remember that you are always subtracting no matter what, whether you have negatives or not. So we have c to the negative 1 minus 5, d to the 3 minus negative 4. would C's new exponent be? Negative 4. Sorry, I was thinking that was 3. It'd be negative 6. What would D's new exponent be? 7. Can we leave this as a final answer?
No.
No. So we would need to change this to what? What would this be as a combined fraction? D to the 7th over C to the 6th. So it's okay if you have negative exponents at first, as long as you don't end up with negative exponents.
If we ever wrote like the 1 over C to the 6 times E to the 7, would that still be correct, or do we have to make it?
You have to make it one condensed fraction. Right? What about this one? Do we have like bases here? Yes. We have x's, we have y's, we have z's. So we have x to the 2 minus, what is our exponent here?
1.
1. Y to the negative 1 minus 4. And z to the 4 minus negative 3. What would x's new exponent be? Yeah.
It was 1.
What would y's new exponent be? Negative 5. And z? 7. This would not be our final answer because we have a negative exponent. This would become 1 over y to the 5th. What would our condensed fraction look like? Correct. Now, some of these other problems are poorly placed. I don't know why they're here. But here you have an exponent being raised to an exponent, but it's a fraction. So you're going to do that to both. 4 to the 1 times 3 over 5 to the 1 times 3. So this becomes 4 to the 3rd over 5 to the 3rd. What is 4 to the 3rd? Use your calculator if you don't know.
64.
64. 5 to the 3rd. 125. Using your alpha of y equals, I need you to see, can this number be simplified? 64 over 125. I don't think it can, but. Can it be simplified?
No.
Now we're going to do that same thing with variables. This exponent goes to both, or all three, I guess. the 1 to the third. Again, once you figure out that you don't need to do this, you don't have to. I'm just going to continue until we get a good grasp on this.
Can you swap around?
X to the first to the third all over y squared to the third. Here we have 4 to the third. Here we have x to the third. Y's new exponent would be 6. Do we have any like bases? No, so we can't condense them, but we can do 4 to the third, which we just figured out is 64. So 64x to the third over y to the 6th is our final answer for that one. And then we're going to do this last one. Now, before we do anything, do we have like bases? Yes. Simplify those first. Do that first. Here, we are dividing our like bases. What are we doing with our exponents? Subtracting. What will m's new exponent be? 3. Now we're raising a power to another power. What are we doing with that exponent? Or what operation are we doing? Multiplying. Multiplying -4 to 1 and -4 to 3. Here we have 2 to the -4. If we multiply these, we have -12. We can't leave these as negative numbers. We need to switch both.
So the -4 would be m or 2.
Both. This would be 1 over 2 to the 4th times 1 over m to the 12th. What is 2 to the 4th? 16. And if we combine these two fractions, our final answer would be what? So we figured out that 2/4 is 16. But this is in the denominator. Correct. The next page of your notes has all of these different rules, but it doesn't tell you which ones you're using. There are strategies.
Could you go back to this?
I will here in 1 second. On this page, there are strategies to kind of help you do what first, do whatever first. Make sure you read over those. For the rest of the time you have in class, I want you working on that page. Where did you need this?
The bottom.
I'll scroll back to it here in 1 second.
No. Thank you.
So this page. Yes, it's a lot. And I want you to try and see how far you can get. If you can get at least one of the columns done before we go, then you won't have homework. I don't want you to do all 24 for homework. I do want you to do one of the columns. If you don't finish one of the columns, that is your homework.